We use electricity every day. It powers our homes and our gadgets. But have you ever wondered how electrical energy is stored? That's where capacitors come in. A capacitor is like a little reservoir for electricity. It stores electrical energy for when you need it most. Think of it like a water tower. The water tower stores water high up in the air. When you turn on your tap, the stored water comes rushing out. Similarly, a capacitor stores electrical energy and releases it when needed. Capacitors are essential components in many electronic circuits. They come in different shapes, sizes, and materials, each designed for specific applications. From tiny capacitors in your smartphone to large ones in power grids, these components play a vital role in our electrified world. But how do capacitors actually work? Imagine two metal plates separated by a non-conductive material called a dielectric. That's basically what a capacitor is. When you connect a capacitor to a power source, like a battery, something interesting happens. The positive terminal of the battery pulls electrons away from one of the plates, making it positively charged. At the same time, the negative terminal pushes electrons towards the other plate, giving it a negative charge. The dielectric in between prevents the charges from flowing directly between the plates. This separation of charges creates an electric field within the dielectric. The electric field is like an invisible force field that stores the electrical energy. The amount of energy a capacitor can store depends on its capacitance. Capacitance is determined by factors like the size of the plates, the distance between them, and the type of dielectric material. The story of the capacitor begins in the 18th century with a device called a condenser. In 1745, German scientist Ewald Georg von Kleist experimented with a jar filled with water and a wire. He found that this setup could store a significant amount of electric charge. Around the same time, Dutch physicist Peter van Musschenbroek independently made a similar discovery with what became known as the Leyden jar. The Leyden jar was an early type of capacitor that demonstrated the ability to store static electricity. The term capacitor came later, reflecting the device's ability to store electric charge or capacity. Over time, capacitors evolved from those early Leyden jars into the compact, efficient components we use today. Materials and manufacturing techniques improved, leading to smaller sizes and higher capacitances. Capacitors are everywhere in the world of electronics. They filter signals, smooth out voltage fluctuations, and store energy in circuits. Open up any electronic device, and you'll likely find capacitors of various shapes and sizes. One fascinating application is in condenser microphones, which are widely used in recording studios and broadcasting. In a condenser microphone, a thin diaphragm acts as one plate of a capacitor. Sound waves cause the diaphragm to vibrate, changing the distance between the plates. These vibrations alter the capacitance, generating an electrical signal that corresponds to the sound waves. This signal is then amplified and recorded. Condenser microphones are known for their sensitivity and accuracy in capturing sound, making them a staple in the audio industry. From storing energy in electronic circuits to capturing sound waves in microphones, capacitors play a crucial role in shaping our technological world. As we continue to innovate and develop new technologies, the importance of these versatile components is only set to grow.